So complex numbers, what is that all about? So complex numbers came about with this question. How do we solve the equation x squared plus 1 equals 0? So mathematicians were stumped by this question and they had to contrive an entire new number system that could help to deal with it. And that, of course, is called the complex number system. So if we have x squared plus 1 equals 0, and we subtract 1, we get x squared equals negative 1, and then we take the square root of both sides, we ended up with x squared equals the square root of negative 1. So what does this even mean? How does it even work? And it does have some applications in electrical engineering and such, but how do we deal with this mathematically? Well, mathematicians said this. They created a new definition. So, a new definition. And sometimes a definition is something that we just have to simply accept, and this is one of them. The fact that the square root of negative 1 is equal to I. So, I is the square root of negative 1. Sometimes things make sense the way they're defined. Like this is a marker. Why is it a marker? Because it marks. This is a phone. Well, who decided it would be called a phone? Well, that's just what it is. It's a phone. It was defined to be that. A chair was defined to be a chair. And it's something that we just accept. And this is one of those things. This is a mathematical definition. The square root of negative 1 is I. So, it's the imaginary unit, I. And once again, this is its definition. And if we can accept this definition, then we can then use it within the powers of I to find new values. So, I to the first, of course, is just I. But if I, by definition, is the square root of negative 1, then I squared is going to be equal to negative 1. Well, why? If we have the square root of negative 1 and we square it, that gives the square, undoes the square root, and we're left with whatever number is underneath the radical, which is negative 1. So we get negative 1. So I to the first is equal to I squared is equal to negative 1. I to the third is I squared times I. And if I squared is equal to negative 1, then negative 1 times I is equal to negative I. So I to the first is I squared is negative 1, I to the third is negative I to the fourth is equal to I squared times I squared, which by substitution would be negative 1 times negative 1, which would be 1. I to the first is I squared is negative 1, I to the third is negative I to the fourth is positive 1. And then if we keep going, we're just going to end up with the same things over and over because this pattern repeats. So if we looked at I to the fifth, it would simply be I to the fourth times I to the first, which would be 1 times I, which would just be I. So we can do every subsequent power of I in the same way. I'll show you one more. So let's say we look at I to the 78th power. So I to the 78th. Well, how could we write this? So first of all, if we say 78 and we divide it by 4, it goes 1 time, 3 left over, 9 times, remainder 2. So we could write it like this. We could say that 78, I to the 78th, is I to the 19th, other way around, I to the 4th raised to the 19th power. So why? Because 4 times 19 is 76, and then plus 2 more, I squared would be 78. 4 times 19 is 76, and then plus 2 more is 78. And of course, I to the fourth is 1. So if we have I to the fourth, which is 1, raised to the 19th, that's still 1 times I squared. We have 1 times I squared. I squared is -1. So we end up here with really -1. So I to the 78th power is equal to -1. Now the easiest way to think about this, and it's just kind of a quick trick, is when you do the division, you just look at whatever the remainder is. And whatever the remainder is the easiest way to make a substitution. So I to the 78th is simply equivalent to I squared, and of course I squared is equal to -1. So that's the shortcut for simplifying powers of I. Now, we sometimes are going to have to simplify radicals using I. Now here's the deal. We are always going to take the I out first. So what does that mean? Well, the square root of -36 is the same thing as the square root of -1 times 36. The square root of -1, of course, is I, and the square root of 36 is 6. So the square root of -36 simplifies down to simply 6I. Do the same thing with the 80. So this is the square root of -1 times the square root of 80, which would be I times the square root of 80. 80, of course, is 16 times 5. So the square root of 80 is 4 root 5. So to simplify the square root of 80, that is 4I root 5. Please be certain that you always put your I in front of your radical, because it's never going to be underneath a radical. Now when we have multiplication down at the bottom, once again, we're still going to take out the i's first. So the square root of -10 would be I root 10. The square root of -20 would be I root 20. So using the commutative property here, we get I times I, which is I squared, and then 10 times 20. And then if you think about 10 times 20, I'll leave the I squared there for now. 10 times 20 is 10 times 10 times 2. What's going to come out of this radical? 10 is coming out. I squared is -1. So -10 square root 2. So square root -10 times square root -20 simplifies down to -10 root 2. We also can perform operations with square roots of negative numbers, but once again, the i's have to come out first. So this is I square root 18 minus I square root 8. So we can simplify these radicals, which you should be able to do quickly. So the square root of 18 is 3 root 2, so 3I root 2. The square root of 8 is 2 root 2, so 2I root 2, which these are like terms, which means that we can combine them. 3I root 2 minus 2I root 2 leaves 1I root 2 as the simplified result. Over here, take out the i's, and we get -2 minus I root 5 times 3 plus I root 7. And of course, this is a binomial times a binomial. So we need to use the distributive property twice, or the Boyle method, whatever you like to call it. So from here, this -2 will first be distributed to both terms on the right. -2 times 3 is -6. -2 times I root 7 is -2 I root 7. Now we're going to take the negative I root 5 through the second set of parentheses. That will be -3I root 5. And then finally, negative I times positive I is -I squared. Root 5 times root 7 is root 35. Now our last step is to simplify that I squared. I squared, of course, is equal to -1. So basically all it's going to do is change that sign, and we end up with -6 minus 2i root 7 minus 3i root 5 plus root 35. And none of these terms are like terms. In order to add or subtract, both the variable has to be exactly the same and the radical has to be exactly the same. Not an or situation, but an and, a biconditional situation. So that is completely simplified. And those are the basics of the imaginary number